As we learn chemistry this semester, a lot of our problems are going to involve various quantities or numbers. Some of these numbers are going to be really, really big. Some of them are going to be really tiny. And in order to deal with that wide range of numeric values, it's going to be easiest if we can use scientific notation. Now, in this video, we're going to discuss converting between standard and scientific notations. Then I'm going to talk about how to handle arithmetic, so addition and subtraction and multiplication and division without using a calculator. Now, the last piece of using scientific notation is actually using your calculator with these numbers. There's some tricks and tips that I have for you. And so we'll go through some of those a little bit later. Numbers in scientific notation are always written with one digit to the left of the decimal. There can be any number of digits to the right. And then there's an exponential factor that is a power of 10. And the exponent we're going to find by counting how many places we had to move the decimal point to get that one digit on its left. A positive exponent is going to tell us that we have a really big number. And a negative exponent is going to tell us we have a number that is much less than 1. If we have a large number, something like 4,390,000, say, then in order to write that number in scientific notation, we're going to start by putting the decimal at the end of the number. Then we're going to move the decimal until there's only one digit to the left of the decimal point. In this case, we have to move the decimal 6 places to the left. What that means is when we write this number in scientific notation, we're going to get 4.39 times 10 to the 6th. Our number is really big, so our exponent has to be positive. For a tiny number, something like 0.000582, we're going to start again where our decimal is, only this time we're going to be moving our decimal to the right. And so we move it 1, 2, 3, 4 places until we have one digit to the left. And that number in scientific notation would be 5.82 times 10 to the negative 4th. On the other hand, if we have a number in scientific notation, we might want to convert it back into standard notation. In order to do that, we're going to rewrite the number without the decimal. Okay, and then we're going to look at this exponent, which is a 4 in this case, and we're going to move the decimal 4 places from where it started. Now we have to add in our zeros, and 28,600 is the answer that we get in this case. With a negative exponent, we're going to be moving the decimal back the other direction, so to the left. And in this case, since we have a -2, we can say our 1742, our decimal is going to start right here. And then we're going to move it 1, 2 places, which means we're adding in 1 0 to give us our final answer. The rule for adding and subtracting numbers in scientific notation is that the exponent part of each number has to match. So if we wanted to, let's say, add 4.32 times 10 to the 3rd with 1.8 times 10 to the 5th, since the 3rd and the 5th are not the same, we're going to have to rewrite some of those numbers so that the exponents do match. So there are two ways that we can do it. In the first way, we can convert our 1.8 times 10 to the 5th to 180 times 10 to the 3rd. So since we went from 10 to the 5th to 10 to the 3rd, okay, that is a difference of 2, right? 5 minus 3 equals 2. And so we have our 1.8. We're moving that decimal 2 places so that we now have an exponent of a 3rd. Once we've done that, we can then line up our numbers just like you would expect. Remember, there's a decimal at the end of our 180. And so we line up our decimals, add the numbers, and get our final answer. The problem with that is that it's in improper scientific notation. It has 3 digits to the left of its decimal. And so we have to move that decimal back 2 places, which gives us our final answer of 1.8432 times 10 to the 5th. In order to avoid having to rewrite our number at the end, if we convert both of our numbers to the larger exponent, it's going to simplify our final answer. So if we have the same addition problem, instead of converting our 1.8 times 10 to the 5th, we can convert our 4.32 times 10 to the 3rd. Since we're going to a larger number, larger exponent, we're going to move that decimal 2 places to the left. Then when we line up our numbers and actually do the addition, our answer is going to come out in proper scientific notation automatically. We're not going to have to convert that number to anything else. Notice that the exponent part of the number that is the answer is the same as the exponent part of each of our input numbers, the numbers that we added together. Don't add or subtract the exponent parts when you are adding and subtracting numbers in scientific notation. Now, I haven't worked a subtraction example because really addition and subtraction are the same thing. The same rule applies. You've got to make sure that your exponents match and then do the subtraction. That'll give you your answer. For multiplication and division, now we're going to have to modify the exponent parts as well as the number parts of our scientific notation numbers. So let's say we wanted to multiply 4.8 times 10 to the 3rd by 2.5 times 10 to the negative 5th. We start off with the number parts, the parts that have the decimal in them. And in this case, 4.8 times 2.5 is going to give us 12. The second part is to either add if we have a multiplication problem, or subtract if we're doing division, the exponent values. So our first number is times 10 to the 3rd. So we start off with our 3. Our second number has 10 to the negative 5th. I'm going to add 3 plus negative 5. That's the same as subtracting 3 minus 5. And my answer is going to be negative 2. Then I'm going to write my answer as the multiplication product of the two numeral parts times 10 to whatever that exponent that I just calculated is. This now is in improper scientific notation, so I'm going to convert that by moving the decimal to 1.2 times 10 to the minus 1. As another example, let's say I wanted to divide 1.75 times 10 to the 12th by 3.5 times 10 to the 4th. Again, the first step is to just focus on the number parts, those numbers that don't have any exponents. And 1.75 divided by 3.5 gives me 0.5. Now I need to subtract the exponents. Since I'm dividing, subtraction is the way to go here. So 12 minus 4 gives me 8. And in that case, my final answer is 0.5 times 10 to the 8th. Again, I have to convert this in one last step so that it is 5 times 10 to the 7th. And that is the answer that I would report. Every calculator is going to be a little bit different in the way that it displays numbers in scientific notation. In general, you're going to be looking, when you're inputting numbers in scientific notation, for a button that's labeled with 2 capital E's or that says EXP, usually in all caps. A lot of the times you'll also see a button that has a lowercase cursive e. That is a different constant number. It has to do with logarithms and not scientific notation. So don't use that button. It'll mess everything up. Using 10 raised, there's a 10x, 10 to the xth power button on some calculators. For that, you can use that. You want to make sure you use parentheses. What you don't want to do is type in, say, 1.6 times 10 raised to the 4th power. That's going to give you the answer. That's going to give you an answer that's off by a factor of 10. The display of a scientific notation number is going to vary depending on the type of calculator you have. And so the 3 figures that I have here show you some examples. The one in the middle, I think, is my favorite because it does say times 10 right there, and then has that exponent. So this number is 1.2447063 times 10 to the 20th power. Okay. The one on top that just has this little 45, that is the exponent part of the number. And so if we were going to write this number by hand, it would be 5.23 times 10 to the 45th. The bottom figure uses a little capital E. It's like half the size of the numbers, and that E means times 10 raised to some power. That's what you get, that little capital E, on like a Texas Instruments graphing calculator when you push the EE or the EXP button. I'm going to move into some specifics now. Most of the students that I've seen have one of 3 types of calculators, and most that I'm seeing have the TI-84 Plus, which looks like the figure that you see here. If we zoom in on the buttons that you're going to want to use, you see they look like this. And so I've just cut off the screen and the number pad. And in order to display a number in scientific notation, you first want to push the second button, that blue button up in the corner. And then you're going to push the comma. When you do that, you can see right in there is the little double E. That is the exponent function. Okay. There are other more basic calculators that a lot of students use. This example is a TI-30XA, and it has a very similar functionality, except it's actually a little bit easier. You've got this button right there labeled EE. And so all you have to do is push that one button and you'll get the exponent. The TI-30X2S is going to function a lot more like the graphing calculators. You'll need to hit second, and then the x to the -1 button will give you the 2 E's. So that's how you would go about that. Casios are a little more rare, but some students do use Casio calculators. And in this case, you would just use the EXP button to give you that scientific notation.